All right, so we're moving on to this last example of serial communication for the time being, and I'm using a slightly more complex sensor this time. It's really just two analog sensors and a switch, but it's all wrapped together inside of this nice little joystick, right? So it's two potentiometers. One is on the x-axis, one is on the y-axis. Then there's a push button. I don't know if you can hear that, but it's like got a little click button there. And so as you can see in this schematic here, this is how it's wired up. Again, I'm using digital pin 3 in my actual circuit, but pin 2 should work for all of you. Um, so this works in a slightly different way than most other switches, and I'll explain that in a minute. But what it does is, opposed to going high when it's pressed, instead it goes to ground. And so we can use a different kind of input configuration in the Arduino called input pull-up. Don't get too hung up on that. Really, what I'm more concerned about you knowing here is how to send and receive data efficiently. So you've got information going from the microcontroller to the Arduino to your P5 sketch and back, but then also how you can send multiple sensors at the same time. So in this example, I've got three sensors. It's effectively two potentiometers and a switch. And I'm going to use that to control a simple Etch-a-Sketch kind of application that I did in p5.js. So when I move the joystick around, it's going to draw on screen. And when I click, it's going to erase whatever is inside of there. So let's look at the code for the Arduino. This is actually based off of the serial call response ASCII sketch that's inside of the examples folder in the Arduino IDE. So if you want to find it, you can go File, Examples, Communication, and you'll see right here, serial call and response ASCII. And for all of these examples, there's a corresponding max patch and a corresponding processing patch, not a P5 sketch or processing sketch. So if you're more familiar with regular processing, you can use that instead. So here I've got um, variables for my sensors, right? So first sensor, second sensor, those are the potentiometers. It's x-axis, y-axis, and then the third sensor is my switch. You can use really anything that you want here. Um, these are just the ones that I have. And then I've got this other variable here called inByte. And so this is going to be receiving a byte from P5. And what the reason that we're doing this is so that we don't overload the serial buffer on P5 with a bunch of information when it's not ready. So the real trick in this particular example is that the processing sketch asks for data when it's ready, and the Arduino sends it when it's requested. So this is also like a very efficient way of dealing with data. So here we start serial communication, and I'm configuring pin 3 in my sketch as an input pull-up. This is a particular kind of, as I said, this is a particular kind of electrical configuration where when I press the button, it pulls it to ground. It doesn't go high. So I will add a link to this sketch here so you can see exactly a little bit more information about that if you're curious. Also in setup, I've got this function here called establish contact, and this happens and runs prior to any meaningful data from the sensors getting sent. And so I'm going to skip down here and look at this real quickly. So establish contact is a function that waits until the Arduino receives serial information from the P5 sketch. So while there's nothing inside of the Arduino serial buffer, every 300 milliseconds it sends out three pieces of data, just a string of zeros. Once a piece of data comes from P5, then we escape this and we go into our loop. So uh, in the loop, what we've got here is everything's wrapped inside of an if statement. So the microcontroller is only doing something if it receives something from p5.js. If there's nothing in the serial buffer, it just skips this entire block and just goes back and checks again. So if there's serial available, then we read that byte and we aren't going to do anything with it. We're just reading it to clear the buffer and we forget about it right away. If you wanted to, you could send meaningful information back to the microcontroller. So maybe you're sending something to control the brightness of an LED or the speed of a motor or the sound that's coming out of a connected speaker. But in this example, we aren't doing anything with it. So we read the sensors, so analog inputs, digital input, and then here what I'm doing is I'm mapping the values to on the Arduino side to something that's usable inside of my P5 sketch. Now you can do this on either side. I just happen to uh, do it on this side because that's how I wrote it. But again, you can do it any particular way. So this is my x-axis. So I'm mapping 0 to 1023 to 0 to 511, which is the size of my P5 sketch. And then here on the second sensor, which is my y-axis, I'm taking a value of 0 to 1023, and I'm mapping that, and I'm flipping that, so 511 to 0, and that's because the axis on my joystick is inverted from my perspective. So this, again, is just to make it so that I have a more meaningful relationship between the motion on the joystick and what happens on the screen. So, and then all I'm doing here is just saying, send out the sensor values. And you'll notice I'm saying serial.print first sensor followed by a comma, serial.print second sensor followed by a comma, and then finally I'm saying serial.println with the third sensor value, which is going to be a 0 or 1. Now, the println, remember, indicates the end of a line. And so doing anything beforehand is not going, sending an ln with any of these is not going to be particularly useful. In fact, it'll screw things up. So make sure that you're sending serial print for when you're sending out your sensors and your delimiters, and you're sending println when you're sending your final bit of data. So I'm going to move this away. And here inside of the P5 sketch, I've got some of the normal serial stuff that we've seen. I've got an array right here for the sensors, and so this is an array that's going to hold the sensor values. And then I've got these two variables for px and py, which is going to help me draw things. So I've got the serial constructor. I'm opening up the right serial port. I'm saying this is what I do when I get serial data. I only need one of those. And then I've got this other thing here. And so the serial on open. So when we open the serial port in our sketch, we're going to call a function in this particular sketch. We haven't done this before, but I'll explain why in just a second. So inside of the draw, this is where I'm taking the sensor data, the X, Y, and I'm using it to draw a line, or I'm erasing the background if I receive a 0 on the switch being pressed. So let's get into the handling of the data. So first, when the serial port is open, we just print out a little diagnostic thing saying it's open. And then I'm calling serial.clear. So what this does is it clears all information that's inside of my computer's serial buffer. It just erases that. So, and that's because the Arduino is sending all those zeros. So this is erases it. So the next thing that I receive is valid data. And then here, I'm sending a serial.write. I'm sending a byte back to the microcontroller. And if you remember, that if statement inside of my loop wraps everything up. So when the Arduino receives this A, and it could be anything, it could be any singular character, it then goes through, reads all the sensors and sends back the information. And when we do that, it fires the got data function. And we read the current line, so up until that println, into a string. We trim off any white space. We just make sure that there's actually something in there. And then what I'm doing here is I'm using this method called split. And what it does is it looks at the string, and then the second argument here is the delimiter. So the thing that's separating the bits of data. I was using a comma. You could use a period. You could use the letter Q. You could use anything that's useful for you. Commas, periods. Those are common delimiters. Um, so when I do this, what it does is it automatically populates that sensors array with the values from in sensor 0, sensor 1, and sensor 2. So my X, so we can see up here, X, Y, and then the button for erasing everything. And I print it out to the console so I can just see it. And then at the end, I ask for more data because P5 has now processed that information. It's going to do something with it. And so here we can see this is basically asking for more. So I've got my P5 serial control application open off to the side here. I'm just going to move that out of the way. And I'm going to run this. And when I do, you'll see down here at the bottom, we've got a whole bunch of data coming through. This is the X, the Y, and then the value of the button. And we can see there's a little bit of a mark here. I'm going to move this over so y'all can see everything. And so now inside of here, if I start to move this around, I can start to draw stuff on screen. And if I click, it erases everything. So this is how we can get multiple pieces of information. This is not the greatest drawing tool, but it's still kind of fun. This is how you can go and you can get multiple pieces of information into a P5 sketch with a microcontroller. Again, you can use any kind of sensor you want. You can use more than 3. You can use less than 3. This is just a good starting